Now let's get an overview of what a typical computer network may look like and how it connects out to the internet and gets web pages from a web server. First, we have the wireless access point, or WAP. And no, it's not the same WAP as Cardi B's. Then we have a laptop or PC. Then the computer sends data out to the internet, requesting that a web server sends data back so you can load a web page for the user. The laptop can use the wireless access point or be directly connected to a switch. The switch moves the request data from the laptop device onto the next device within the same network. It can't send data to another network. It can only move around the data within the same network. That's why the switch sends the data to a router, which moves the request data from one network onto another network. It basically helps connect different networks with one another. It's the traffic cop that tells data traffic where to go based on its destination. Depending on the starting network's internet service, they may have a modem or an ONT. A modem modulates and demodulates the data signals coming to and from your network. It converts the digital electrical data signals into analog signals that can be sent over cables and phone lines. If they don't have a modem, then they have an ONT, or optical network terminal, which is used to connect the starting network to a fiber optic network. It converts the fiber optic signals into electrical data signals that the router, switch, and computer can read, and vice versa. So basically, both a modem and an ONT convert a network signals so that they can be read by other devices. Then we have the starting network's internet service provider, or ISP's router. Their ISP's router then connects to the router of the web server's ISP, which likely goes back to the ISP's modem or ONT, leading back to the router of the company hosting the web server, which leads back to the company's switch, finally leading to the web server, which receives the request data and sends back the data for the web page. So these sides of the network are LANs, or local area networks. LANs are made out of routers and switches, which allow devices like computers and printers to talk to one another within a small area like a home, office, or school. By being connected to one another, these devices can share data and resources. For example, you and your coworkers can print to the same printer. Or, as another example, you and your friends and family can connect to the same Wi-Fi network to access the internet. Then we have WANs, or wide area networks. These networks span large geographic areas like cities, states, or the whole world, as in the case of the internet. BGP, or Border Gateway Protocol, is a type of routing protocol or set of rules that allow routers to exchange travel path information between different systems on the internet and then send data using the best possible path. This protocol is what keeps the internet traffic reliable and efficient. These interconnected systems that the internet connects are called autonomous systems, which are groups of connected networks that are controlled and managed by a single organization. For example, all Verizon routers would be in the same autonomous system. So, let's say your ISP's router may be an autonomous system 701. Meanwhile, the ISP of the company hosting the web browser may be in autonomous system 32934. BGP allows them to share their routing paths with one another so that the data from either side can reach the other. At home, you may be thinking you only have a router, not a switch. Well, sometimes we have combined routers and switches, such as this Verizon router. In a larger company or school network, you may find combined routers and switches called layer 3 switches. So these layer 3 switches can route data between different networks and route data within the same network as well. The difference between layer 3 switches and our home combined router and switches is that layer 3 switches are more powerful and versatile. Layer 3 switches can handle complex routing. It can support multiple protocols or rules, and it can handle a larger number of connected devices. Now, let's look at a typical home network, which may be the type of network you're currently using. First, we start with your laptop or desktop. Your laptop or desktop is going to send a request to a web server to get a web page loaded onto your browser. Your laptop may be connected through Wi-Fi to a combined switch and Wi-Fi router provided by your ISP, which is then connected to a modem or ONT. The modem or ONT converts your request data signal so that it can travel to your ISP, landing your data into your ISP's router, which then routes your data to the ISP router of the company hosting the web server. The data then goes to their modem or ONT, where the signal is translated back into electrical data signals, which goes to the hosting company's router, probably in a data center. The data is then sent to the company switch, finally landing at the web server. The web server would then send back the data of the web page so your computer can receive the data and load the web page. As mentioned before, these sides of the network are separate local area networks, with the middle portion being a wide area network. In this case, the wide area network is the internet, which uses BGP routing protocol or rules to route traffic between Autonomous System 701 or your ISP's AS and AS 32934, which is the autonomous system of the ISP of the company hosting the web server.